Hello, welcome to my conceptual organic chemistry series classes. Today I am going to start amine and class number is 4. Before starting the class, I am giving you some tips about the organic chemistry. Many of time in my life I have seen the student is afraid of organic chemistry and they very easily do not want to take organic chemistry interestingly. Actually, in my life, I have taught 12 years in colleges, and what I say is from my knowledge, and it is hard reality. My lecture is not exaggerated with false assurances or with bombastic words. What I say is from my experience. Today, I will show you some techniques with the help of which you will grasp organic chemistry, and organic chemistry will be in your hand. If you just follow me, and it's my assurance, organic chemistry will be in your hand. Don't miss my class and listen to it patiently from beginning to end. So today, whenever you want to listen, you just blank your mind, assuming that you are a layman, you don't know anything, you do not have a knowledge, ABC knowledge on organic chemistry. I will make operation of the chapter of amine. I will operate each and every part as a doctor operate a human being. I will operate whole amine chapter as a doctor, and you will just follow me how the operation is done. So before operation, first of all, a doctor must know the internal organs, huge concept regarding the body organism, their functions, their effect, and also are there any related disease like diabetes or high pressure or hypertension, all of these. If there are some types of disease before major operation, the doctors need some precaution before going to operation. So before operating the chapter amine, I will first find out what are the factors and what are the things to be rectified and what are the knowledge to be drawn out of this chapter. And you will find the chapter very easy, then you can operate the chapter yourself as an expert doctor. Okay? So, amine. The scheme of chapter is very simple. First, introduction. Second, classes. Three, chemical reaction. Four, physical behavior. Five, uses. And now let me explain what are the things or what are the facts are hidden in the chapter. Let me explode it one by one and explain it, and you listen minutely so that your operation part will be very easy. Chapter analysis. Number 1, reducing agent which are used. these are the reducing agent used in the chapter. Not a single one is out of this. Lithium aluminum hydride, alkali, nickel or ready nickel platinum, etc. Nickel palladium, ethanol, HCl, iron, HCl. And on the oxidizing one is oxidizing one is KMnO4 alkyl. So these are oxidizing and reducing agents. Now, what are the things are done here? Reagents. Minutely follow. H2SO4 concentrated. H2SO4 concentrated, HNO3 concentrated. This is nitrating mixture in earlier class number 3 I have shown you. Nitrous acid, which cannot be found in laboratory, it is prepared in situ. What does in situ means? In the reaction mixtures we will use another two reagent, and these two reagent will combine to give you NO2. So HNO2, Na2, sodium nitrite, out of this you will get this. This type of preparation in the reactions where a reagent used which is unstable cannot be found in laboratory is prepared out of the reaction from other two reagent during the time of reaction is called in situ preparation. In situ preparation. And other one is I will show you fluoroboric acid. You will find this is extensive use. Fluoroboric acid, another is I am rubbing this one, Gibbs reagent, very important one. Just Gibbs reagent, Gibbs reagent, is the C6H5, very important one, benzene thiolate chloride. Now we have seen in the chapter what are the reducing agents are used, what are the oxidizing agents are being used, and what are the further other reagents used for another type of reaction. I will show you the uses, Gibbs and Hillsbach reagent. Gibbs is C6H double bond or C2H5 and Hillsbach is C6H5 SO2 Cl. Now we have just learned about head, leg, external parts. Let us come to the internal organ. These are the type of the reaction involved in the chapter, which is all about the chapter M, chemical reaction. I have classified this chemical reaction, which are explained in your textbook, is number 1, Gabriel thalamide reaction. Number 2, Hoffman bromamide reaction. Number 3, Hoffman and his work these are actually method. Number 3, number 4 is Sand-Meyer reaction, Mendias reaction, Balz-Kiemen reaction, and Scott and Baum reaction, Hoffman elimination, Lieberman nitration reaction, etc. So these are the name reaction, the type of reaction which are used in your ME chapter. One is Gabriel thalamide, Hoffman bromamide, degradation reaction, Hoffman-Hinsberg method for separation of 3 types in ME, 1 degree, 2 degree. In the mixture you can take one individually out with the help of this. Sand-Meyer reaction, this is for preparation. I will explain later in details. I am not just explaining the different part which will come in need in operating the whole chapter. Sand-Meyer reactions, fluorobenzene, chlorobenzene, cyanobenzene, and another is left out. I think it is Gattermann reaction, GATTER, Gattermann reaction, and this is also chlorobromobenzene, but the reason used are different. Mendias is reduction of cyanide group, and Balz-Kiemen reaction is preparation of fluorobenzene. I will explain it individual one by one. Scott and Baumann reaction is acylation reaction with amine. I will explain one by one. Hoffman elimination we have got earlier in the first year class. Again I will explain. Lieberman nitroso reaction. The question arrived that this time in NEET a question from Lieberman nitroso has arrived. Appeared. So these are lump sum idea regarding the different part of an organ, like organ, different part of the amine chapter, which if you have thorough knowledge on this, we can proceed very easily final stage of operation. Now these are name reaction. Now what are the other type of reaction? Besides name reaction, other types of reactions are also being used. One is other type of reaction. Other type. Not name reaction. Name reaction are of 10 or 11 type. I have shown you already. Other type is SN2, nucleophilic substitution 2. Electrophilic substitution reaction. Very important this part. Reduction of cyanide group. Reduction of isocyanide group. Reduction of amide group. All will give amine. Reduction of this amine. Number 4 type of the first one is SN2. I will show you ammonolysis. I will explain. Substitution elimination reaction. You will get nitration, bromination, sulfonation. I will explain part by part. Reduction, mind that cyano, isocyanate, amide, and also another is nitro. 4 type of reductions are there in the chapter. I am splitting out the points which will be required in the chapter. Next one is acylation, alkylation, acylation. Next is with Grignard reagent. Here Grignard reagent will react to amine and Grignard react to compound with cyanide. 2 types. Next one is coupling reaction. So in the name reaction you have seen 11 type of reaction I have shown you, and other type of reactions which are being used in the chapters, which are being explained in the chapters are SN2 type of reaction, Ac type of reaction, reduction of CN, NC, CO, NH2, alkylation, acylation, Grignard reagent of these and these two. In 2021, yeah, the question came from Grignard reagent with cyanide. Am I right? And these are the type of the reaction which are explained, which have been explained in the chapter. Now, let us know what are the things we should know before going to operation. What are the other things we should know? These are the very simple things. One is ammonolysis. This is SN2 type of reactions where alkyl part will enter into this one, enter into amine. I will show you later. Ammonolysis. Next one is reactivity of amine. Amine may be aliphatic amine, aromatic amine. So why they are extensively used? Extensively reactive. Compound containing NH2, because there is number 1 nitrogen hydrogen electronegativity difference. Electronegativity difference of nitrogen and hydrogen is huge, and number 2 there is lone pair on nitrogen. Because of these two facts, acidity or basicity or reactions or reactivity depends of amine. Again, I will explain plus I effect and minus I effect upon this. Whenever amine is there, In amine group, there is lone pair. And what is base? A base is a substance which has lone pairs and which are available for bonding. These are base, so no doubt amine is base. Am I right? Amine is base. But if I now tell you alkylamine and arylamine, the basicity of these two are not same. So there are some factors on which basicity depend. In short, one of the very important thing which I want to explain here is amine is activating group. It is very important. Amine is activating group because that lone pair of electron enters in resonance. So what's happened? In this way, the process will go on. You will get a lot of canonical structures. I have shown this only because of the fact that the basicity of a substance depends upon the lone pair, presence of lone pair, and availability of this lone pair electron for bonding. So if this by some means, by any means, if this lone pair is engaged and not readily available for bonding, then this base will not be a strong base. So basicity will be low. So in alkyl amine, lone pair is not resonance hybridized, but not involved in resonance. But in aniline, this lone pair is involved in resonance like this. Hence, aniline or lone pair of aniline is not readily available for reacting, but yeah, it is readily available because of the fact of plus I effect. It pumps electron, so this lone pair readily available for bonding. Next one is pKb inversely proportional to 1 by basicity. I have earlier shown you the acid in carboxylic acid chapters. Here another part you will get is 1, 2, 3 and this is 4. Ammonolysis I have already explained, and metamerism. Metamerism, you will not get this term directly, but there is a compound in your test and you are asked to find out number of isomers, and you please try to do at home. You will get 8 isomers. First you change, right in change was CH3, CH2, CH2, CH2 and H2, and you go on changing the change CH3, CH3 2 position, 3 position, 1, 2, 3 position, like this you go on changing the C in the change. Am I right? 1, 2, 3, 4, then you make change, you bring here this C, keeping NH2 intact. Then now metamerism is a concept. Actually, you have got it in a higher secondary first year. I don't know have you done it or not. Say this is a compound like this. You can take one this here, again here, and keeping this in same position. Right side CH2 will take it to the left and left side to right, and that's in this way you make change. You will find different structure. This is metamers. And this metamers is not shown in ether, it is also shown when N is there or N is sulfur is there. In your book it is only, in first year it is O is given ethers. I think it is N and S. So here also when you go on writing the isomers, you will get N. You change CH3 by changing CH2, CH3 like this. Am I right? Like this. Again you make it here, you make it there. You metamers. I will get 4 metamers. That's why I have introduced the term here in this chapter, metamerism. It will come in isomers. Very often isomers of amine used in this. Next one is, fifth one is solvation and steric effect. Very important. Solvation effect and steric effect. Because of basicity of amine, the solvation effect and steric effect come into play. Okay, when amine is in aqueous solution, then solvation takes place. When these are in not in aqueous solution, in normal in position, aqueous solution is not there, so no solvation effect exists. When there is water, there is solvation effect. Now what is solvation actually is ammonia. Say you have given water, you will get NH4 positive plus 4, say OH, like this. So you have seen that at base one hydrogen has been attached here, so you have got a cation of this type. Now the basicity of that part depends upon the stability of this cation. More the stability of this cation, more will be the basic that compound. So if there is more number of hydrogen, there will be hydrogen bonding. When it will be in water, in aqueous solvent, there will be lot of hydrogen. Am I right? So more the number of hydrogen bonding, more will be the stability of cation, and more will be the basicity of that one. Am I right? Now if you decrease it by R, so number of OH, to me solvation effect is now lowering. It will its effect will be less than earlier one. If you now replace that hydrogen by another alkyl group, again you are not getting another OH bond. So more the intermolecular of hydrogen bonding, more is the number of hydrogen in the cation parts. Cation ion part, if there is more the probability of hydrogen bonding, that is more the number of hydrogen, more is the solvation and more is the stability and more is the basicity. So if the hydrogen number is reduced, alkyl parts coming into play, so less will be OH to hydrogen bonding, less will be its stability, less will be its basicity. Or in other words, bigger is the size of this cation, lesser is the solvation, lesser is the basicity. So if you use alkyl in place of H, so you are getting the plus part is bigger and bigger and bigger. So when it's become bigger and bigger, the solvation becomes weaker and stability becomes lowered and basicity decreases. Now what is steric effect? Steric effect is again related to the nucleophilicity, nucleophiles. A nucleophile is a strong or weak, again it depends upon the ability of this pair to attack. Am I right? If the attacking reagent, attacking substrate on which the nucleophile will attack, if it is attached with more and more bulky groups, so there will be less ability. If the attacking reagent containing lone pair is attached to with more and more bulky groups, then it will be less basic. So bulkiness of methyl group is assumed to be negligible. If it is ethyl, it is bulky. If it is more than 2 ethyl, again it is bulky. If it is 3 ethyl group, again it is bulky. So more the bulkiness, less will be its nucleophilic effect. So this is the steric effect. One of the things where you will find the name of the organic compound, you will find very often it is very difficult to keep it in your mind. So from first year again I am repeating one thing. One is benzyl, other is benzyl, other is benzoyl. Actually, when benzene is attached to carbon having 2 hydrogen. If it is attached with two hydrogen, then it is called benzyl. Say, for example, this is CH2Cl. You will name it benzoyl chloride. You can't say benzoyl chloride. You will say benzyl, benzyl, because CH2, hydrogen 2, benzyl. Now, what is benzyl? If there is one hydrogen, if there is only one hydrogen, and whatever other things is attached to it, name will be benzyl. So benzaldehyde, carbon is 1, hydrogen is 1. And what is benzoyl? If there is no hydrogen at all attached to that carbon, no hydrogen at all, that is called benzoyl. You will get the extensive use of benzyl, benzyl and benzoyl. It is from first year, just I am repeating because it will come in need. When you will give the name of the some compound, it will be very often difficult for you to keep it all this in your mind. Now I am in the operation theatre. I will operate in the main part. Main part is preparation. So for preparation, I have telling you, one is ammonolysis, other is reduction of CN, NC, NO2, CONH2. Am I right? And another is Gabriel Thalamide reaction, and other is Hoffman elimination, Hoffman degradation, each and every one. Along with each one, we can prepare. But Hoffman bromamide degradation will use first one. Yeah, degradation. Hoffman bromamide degradation. Hoffman bromamide degradation reaction. So in your chapter, they deal to the preparation of these two ammonolysis. Ammonolysis, say first one, you minutely follow C6H5I Me. So you see, you finally follow. This is ammonia is NH2H. You remove one hydrogen with iodine, HI. You are getting C2H5NH2. C2H5NH2. Again, you add up C2H5I, first one. Am I right? So that was, we are just replacing NH3, we have replaced one hydrogen and ethyl part, and here again we will replace another hydrogen in alkyl part will come here. So along with nitrogen you are getting C2H5 and this C2H5. In nitrogen you are getting two C2H5. C2H5 twice along with nitrogen, and one hydrogen is replaced by this one, means they are left one hydrogen. Am I right? So this is lone pair, that's why this is lone pair. This is SN2 type of, I will show you then reaction later on. Again we will go on adding ethyl group until and unless there is lone pair. C2H5I. If it is 2, then we will add C2H5. One hydrogen is there. Am I right? So we replace that hydrogen by C2H5. And you will again add up C2H5. It will be tertiary ammonium salt. 4NH4 plus Cl. Am I right? This process is called ammonolysis. You see, in the process you are getting 1 degree amine, you are getting 2 degree amine, you are getting 3 degree amine, there is mixtures. So we can separate out these mixtures by Hoffman methods or by Hinsberg's method I have mentioned earlier. We can separate out. And one of the important condition is that we can get 1 degree amine more if you use more and more ammonia. This is one condition. If you use more and more ammonia, we will get 1 degree amine more. This is first type of reaction. Now, violently follow the second type of the reaction. This is reduction. This is reduction. So, in the reduction process, we can use nickel or platinum. Mind that when we want to reduce, reduction means addition of hydrogen. In cyanide parts there are 4 hydrogen is added, and in nitro, if there is nitro group, 6 hydrogen now. Anyway, I will not go to the tip of this one, detail of this one, class will be lengthy one. So if there is carbon, you make it CH2, you make it CH2. Mind that lengthening of chain. You are getting this, you are getting this, you are getting this, you are getting this out of this. Am I right? Next, sodium, mercury, ethanol. If you reduce it, you will once again you are getting this C. This C will become CH2 again. You are getting new CH2 group, and that CN group has converted into NH2. And this is a special type of reaction I have written in name reaction, Mendius reaction. He has used this reagent to get this, but the product is the same. RCN becomes RCH2NH2, CH2NH2, CN becomes CH2. Where there is CN, you will get on reduction CH2NH2. So you are getting all are 1 degree amine, 1 degree amine, 1 degree amine. Am I right? So if you want to get 2 degree amine, you do one thing, isocyanate. You will get, if you give it here CH3, NHCH3. Am I right? It is 2 degree. I think this year, this question, okay, indeed. In my lecture, I will very often cite NEET and this, and that's only because to make you understand that questions which appears in NEET is exactly on the basis of the concept, not on higher anything else. It is very simple. Now, another, we have prepared 1 degree, we have prepared 2 degree. Now, what is 3 degree? It is Hoffman elimination reaction. Now, I am writing this reaction for your understanding a bit. Mechanism, a very easy mechanism. A base, say this is the base. That base will just abstract out this one. This bond will be withdrawn here, and this is plus. That one will be withdrawn to neutralize this charge. Are you not getting CH2, double bond CH2? In alkene chapter in first year you got this. But today in our chapter we will not be concerned with this. We will be concerned with something else. We will be concerned with this part. This part, what we get is NC2H5 all. Am I right? Is it not 3 degree? That reaction is called Hoffman elimination reaction. Hoffman elimination reaction. So, third type of reaction is CH3 C double O NH2. We are reducing just step by step. You follow this one. You just use lithium aluminum hydride or sodium alcohol, like this. You will get that part will convert into CH3 CH2 again NH2. Fourth part is nitro. In nitro we will use 10 hydrochloric acid. We will get ammonia. Question comes from here. I will show you. Same, I am not writing again. If you use it iron and this, again you will get Me. Am I right? But that method is preferable because of the fact that you will get ferrous chloride, which is unstable, which once again breaks to give you iron and HCl. So in the starting of the reaction, to initiate the reaction, you will use some amount of HCl and iron, and when the reaction proceeds, you will get ferrous chloride that again will breaks up into iron and HCl, and this will act as a reducing agent again and again. So there will be the minimum use of the reagent to get amine at the end. So we have got reduction from Cn, from Cn we get 1 degree, 2 degree, 3 degree, and reduction from NC we get 2 degree. Hoffman elimination reaction we get 3 degree, and amide we get this. Amine you get this water, and from nitro we would get this, and when we use this is preferable because we can use minimum of HCl at the initiation of the reaction. So this is the second part is over. Let us come to Gabriel phthalimide reaction. So in my third class, today's class is fourth class, I told you I am just in very fast way I will show you that was this phthalic acid. That was phthalic acid, and I show you a reaction of this phthalic acid with ammonia. I told you that get attached to this one. You just follow you see the first class, you will find CONH4 positive, CONH4 positive, and then on heating, I told you water molecule released H2O, you are getting NH. Again from here water H2O, you are getting NH. So you are getting this. So it will not be very hard for you to learn, to keep it in your mind. Phthalimide, this is phthalimide. How it come in the conversion reaction if it is given in this way: phthalic acid, ammonia, question mark heat, question mark potassium hydroxide, question mark potassium this. You get yourself if you have the knowledge. So this is phthalimide, and Gabriel has phthalimide has that starting material, and what he did, it is very very important, minutely follow me. What he did, that one that was the starting material. So what happened here is the reaction appears to be like this. very interesting part is here. You see, alkyl halide. I am introducing one alkyl. This is very important part. You just minutely follow. I will show you a trick. It is a nucleophilic reaction. Here this is acting as a nucleophile negative sign. It attaches with this one. It goes out. What I get is this. Am I right? Sodium hydroxide aqueous, NaOH, NaOH. Am I right? You follow me the way to write. So when we use this base, it breaks in this way. You please follow the technique, otherwise you can't. You can't answer. So, are you not this? So the critical concept of this one is you have started with organic aromatic compound, and in the middle of the reaction you have used alkyl halide. Your answer is amine. It is 1 degree amine. So in the reaction, in the exam you may be asked what's happened this. Am I right? You will get 1 degree amine. But why not 1 degree aryl halide? Can you get 1 degree aryl halide? Benzene NH2. Can you? No, will not get. The answer is very simple. If it is aryl, say it is aryl. If it is benzene, say this is X. Am I right? So in benzene, what happened? This lone pair involves in the resonance with the benzene, and that carbon and chlorine bromine, whatever X is there, becomes partial double bond. So what is Gabriel thalamide reaction is that in this reaction there is breaking of carbon and X bond. There is breaking. This is the main concept, carbon and X bond breaking. So carbon and X bond when breaks, we get it. It is not mechanism, it is the other. Actually carbon and X bond breaks. So if in benzene carbon and X become in aromatic compound partially double bond, so it is not easily undergo substitution reaction. As in the first case, it undergoes substitution reaction and we get 1 degree amine. But in case of aryl halide, due to this partial double bond character of X and carbon of benzene, substitution reaction is not possible. So aromatic amine or aniline cannot be obtained by Gabriel thalamide reaction. Very important concept and information you keep it in your mind. And next one is Hoffman bromamide reaction. I have effaced out Hoffman bromamide reaction. Hoffman bromamide reaction is very important for exam point of entrance exam, whatever exam. It is amide. Sodium hydroxide and bromamide means bromine. What we get is again it is amine. It is a very important reaction because it is here there is one carbon less. Starting there was one carbon in the answer, there is one carbon less. Hence this reaction is called degradation reaction. There was loss of one carbon in the final product. So next one is main important part, reactions. These are preparations, reactions. That is reaction as base, reaction as nucleophile. It is a very hard thing, very complicated thing. I know many of you don't know whether base is a nucleophile or not. Yes, base is a nucleophile. So it is, if basicity is more, nucleophilicity may be more. If basicity is less, nucleophilicity is less. Is basicity less, nucleophilicity may be highest. And lots of things are there if I get time. So I will explain you the rule or the relation between basicity and nucleophilicity. So now, how in a reactions a substance acts as a base and same substance in another reaction acts as a nucleophile. It is a third thing. Mind that when it is base, just it will be equilibrium. When it is base, the reaction will be equilibrium. It will form like this. That is, hydrogen or proton get attached with this one. But when it is amine, and if it acts as a nucleophile, it will get attached other than hydrogen, not with hydrogen, get attached with electrophile. Other than hydrogen, that is with carbon, electrophile having carbon, it will get attached with this one. Here in case of base, hydrogen proton is get attached with this one. It is reversible, but in case of this, it is not. If base is a nucleophile, it get attached with this electrophile, which is not hydrogen, other than hydrogen, that is carbon. This is the difference. Base, there is equilibrium, and proton is get attached, and nucleophile, it is get attached with other than hydrogen, that is with carbon. Am I right? This is the reaction. So first of all, it reacts with base. This part is a bit tricky part. I will have to explain a bit later, a bit details. Greater the stability, of substituted ammonium cation, greater is basicity. It is in absence of water. More is the solvation effect on substituted carbonium cation, more is basicity. Number 3, more is steric hindrance, less is the basicity. So I will explain this in 1 or 2 lines in my next class, as the class has become a bit lengthy. So today I want to conclude the class over there, and in the next class I am sure I will complete in the 5th class a whole chapter, and you will be able to understand each one for yourself.